Ursula, are you... oh, there we are.
There we are, right. Well, it's very nice to be here in this community that I'm very much enjoying getting to know. As some people may know, or people who talked to me last year, I'm not a professional, any of the professions of the study of science that are in this room, like philosophers of science or sociologists of science or historians of science. I'm a computer scientist, and what I'm trying to do is understand the practice of mathematics for a purpose, the purpose being to build better computer tools to support mathematics. And I suppose the way I found myself trying to understand the practice of mathematics, having realised, there were some ways that were just looking at myself and seeing how I did it was probably not a good way for all sorts of reasons. The way I've fallen into doing it, so to speak, is through the influence of sociologists in Edinburgh like Donald Mackenzie and Robin Williams. And the piece of work I talked about last year was a piece of work that I did with Alison sitting back there, studying polymath and math overflow, exactly to look at what people did in those systems as evidence of what people were actually doing when they were doing mathematics, and that's a big area of activity that we're going to continue doing. But in this talk, I don't quite know why really. I saw Paul, Alison and I saw Paul, and we thought, well, we could sort of adapt the thinking we've been doing to think a bit about values and what we can see in about values in those sources. And we were also influenced quite a bit by talking to Andrew, who is Aberdeen, who is not here but is ably represented by his co-author Matthew, on the experimental philosophy tradition, particularly the work of Overton. And that was looking for studying the meaning of what explanation meant by looking for the occurrence of a word explanation in papers in general science. Okay, well, so this talk, what can we learn about values from mathematical practice? Crikey. Well, just don't listen to me, just go back and read all the papers that you've heard from the rest of the 3 days. And what was informing us when we were thinking about this was also, can we shed light on the beauty-use dichotomy? And we got some quite trenchant referees' reports back saying, oh, that is such a naive question. That beauty-use dichotomy is something that well, I suppose in the sociology of knowledge or something, as it goes across into thinking about science policy, I don't know what this world thinks of the notion of Pasteur's quadrant. Who thinks it's completely and utterly discredited and silly? Oh, good, nobody thinks that.
I could confess to a high degree of ignorance then.
Oh, I'm sorry, yes, I'm kind of... Okay, so the Pasteur's quadrant was a notion developed in the 60s, and I temporarily had a mind fog as to the name of the person who developed it. But this was fighting against the notion, and this idea developed in the context of arguments about science policy and science funding, and the arguments that said, well, science is either useful, the world of Edison inventing the light bulb, or it's a question of fundamental understanding, signified by Bohr, and of course, we should throw all the cash at this bit. And then this argument.
I understand. So either politeness, the left-hand bottom square has been left blank.
Yeah. well, I could have put myself in. But then Pasteur's quadrant is use-inspired basic research. What was Pasteur trying to do? Well, he was very clearly inspired by doing basic research, and so this notion was put together to say, well, this is really rather a false dichotomy, especially when applied by funding agencies. Okay. in addressing this question, we sort of continued looking at the things we've been looking at before, the actual artifacts of mathematics. Both the front stage, and that term has been used already this morning, the gentleman's front, Goffman's front stage, the performance that you see, and the backstage work and stuff that you don't see, or don't see so obviously, the working notes, the working records, the kinds of things we were just hearing about, or the kinds of online records that are now available. So if we start with, well, the sort of biggest, grandest piece of front stage you can think of, if you start from looking at the products of mathematics in the form of research papers, well, then you start to, you know, if you're being very naive, you say, right, okay, I'll find a bunch of research papers and I'll look through them for value words like truth and beauty and use and so on. And, well, you start at the top with Andrew Wiles. I was rather pleased. We heard this morning, we haven't had a marvellous yet. Actually, Andrew Wiles has a marvellous, and a number of other, oh dear, it's illegible. Andrew Wiles, at the start of his paper, giving the exposition of his proof of Fermat, well, of course, he's on top of the mathematical world, writing in the annals. He's allowed to break all the rules we've just heard about. He's allowed a 10-page introduction in which he uses the word I, he explains the development of the argument, he explains where the proof comes from, and he says things like, in doing this, I came suddenly to a marvellous revelation. I saw in a flash on September the 19th, 1994, or something or other. Well, of course, you know, only Wiles in this paper is allowed to get away with writing that in paper. Most referees wouldn't let you do that. And this paper, Wiles, has a number of value words, if you like. He talks about remarkable observations, critical, crucial things, novel arguments, new and surprising, marvellous revelation. And this is in Alan Bishop's categorisation that we had that for on the first day. These form into sort of mystery, magic, marvellous category of values. But when you actually dig back into the paper, once you get past the introduction, of course you're back to the very flat, neutral language. Well, I mean, the fact that the language is flat and neutral is itself the exemplification of a value, but it doesn't exactly have value words in. Yes, I can't help noticing, mathematicians do love adjectives, really exciting adjectives. That word is not gory, it's allegory, which has got lost. Finite flat commutative group scheme. So look, and then we've got unique finite flat group schemes, not commutative ones apparently, and so on. You know, but they do like adjectives, but they're not terribly exciting. And when you look at the body of this proof for words like beauty or useful, well, you don't find beauty anywhere. You do find a couple of usefuls, just used in the normal English language sense of, yeah, I'm doing this here because it's going to be useful 10 pages further on. Well, that's of course what happens when you look at papers at the peak of the activity. What happens if you look at the more run-of-the-mill kind of work? This is the Journal of Algebra a few days ago, looking at the most downloaded articles from the Journal of Algebra in the last 90 days. Well, you know, you have to come down several thousand feet from Andrew Wiles, looking for statements with values in. Again, they come near the beginning. Only the first hesitant steps were taken so far to study. This present paper provides an in-depth study, so it's the rationale, it's the explanation of why they're doing it, or it's the explanation in public language of why they're doing it. Or another one, this is a really riveting one. Look, more results about CLT groups and related topics can be found in 1, 2, 29, 30, and 31. In this paper, the study of the above topic is continued. Well, this is clearly the value of building on and extending from what we had before. But this one's even better. These are the 3 most downloaded papers. This one's even better. This was the main part of my doctoral dissertation. Here we offer a short and simple proof of this result. The proof is so embarrassingly short as to direct is to make the result unsuitable as a doctoral dissertation. So this is the mathematical virtue of honesty and so forth. Just look at the dates. This paper was written in 2013. His actual dissertation was written in 1952. This is somebody who has carried this anxiety with him.
You think he woke up yesterday and went, oh my god, it's a three-liner. You think he's known this since 1953?
He had known it for rather a long time.
Wow.
They're good friends, maybe.
He must be in his 80s now.
He must be in his 80s, yeah, sorry, I haven't written down who it was. But actually, he then goes on and says his supervisor sort of let him publish the complicated thesis because actually his supervisor already nicked his best result and published it without his name on it. Maybe his supervisor had just passed away because there's a bit in the paper about how various people are now no longer with us. So maybe he'd been waiting. I know not. Anyway.
There's some values underlying our conversation.
Yeah, well, I suppose what I'm saying about here, you know, these things they are full of values, but they're not values you're ever going to discover by a keyword or in search, really. You know, you read them and you know, you might pick up embarrassingly. That's a bit unusual to have, but they're not. You know, it's rather a subtle thing. But these are sort of picking up on. I suppose these were what you were just calling the stable values. The values on the right-hand side. You know, is it new? Is it worth publishing? Those kinds of values. Well, what happens if we start looking at things like abstracts of papers? Again, thinking about motivation, values, and so on. Well, I continue with the Journal of Algebra. Why, you may ask, I tend to do this in the Journal of Algebra? It's because when I used to do mathematics, I did group theory, and I sort of have a hope of understanding a bit more of what the paper's about if I did it in topology journals. But okay, the Journal of Algebra has 17,000 papers. Only 147 of the abstracts contain the word beautiful, 203 contain elegant, you know, a number contain words in that sort of cluster. A heck of a lot contain useful, typically useful in the sense of being useful for other mathematics. You know, the abstract of a paper is the elevator pitch to the paper, isn't it? Here's one I hope you can read. Here's an abstract that contains beautiful and elegant, beautiful and useful. And this is a typical pattern in these abstracts. You never use beautiful to refer to your own work. You use beautiful to add luster to the paper you're writing by saying there are many beautiful constructions of the Hilbert scheme of something or other. You know, in a beautiful paper, some famous person said something or other. Now I'm doing something or other, which in addition may be useful for something or other. And that seems to be, so you can say your own stuff is useful and you say other people's stuff is, that seems to be quite a pattern. But useful, not of course in the grand and glorious sense of being useful to NSA and GCHQ, but just useful for somebody else in your line of work doing something a bit similar. What happens if you go to math reviews? And math reviews is where your peers look at this and summarise what they think the value of them was. Well, if you look at the same chunk of papers in math reviews, we've got rather fewer beautiful, elegants and usefuls. Reviewers don't always share the author's enthusiasm for sticking these words in. But of course, you know, the math reviews also is written in a very formulaic style. You don't find words like ugly, clumsy, useless, not pop, etc. They're all written in a stylized way. Okay, well, what happens if you move now? That's sort of front stage mathematics. And I suppose what I'm trying to say is front stage mathematics, research papers, abstracts of research papers and so on, is not going to tell you a lot if you just search for value words. It is going to tell you a lot if you start digging down into the subtleties of the English language. But if you just do a word search, it's really going to help. What happens when you start looking at backstage mathematics? Well, this is we've heard about math overflow several times this week. Math overflow contains mathematical conversations. And here's one I picked out, which you can maybe read the question if you can't read the rest of it. Here's a question that's inviting people to express opinions and talk about values. What's the most harmful heuristic towards proper mathematical education you've seen, or you've seen taught, accidentally taught, were taught? When did hand-waving inhibit proper learning? Well, that got them going on Math Overflow, plenty of discussions about that. And just for fun, I sat down with another of my co-authors in a coffee shop. We started reading this and looking for value words, and well, as you might predict, an enormous number of value words: failure, problem, setback, hate, harder, trouble, damage, hand waving. Those were negative ones. The ones we had an argument about: bash blindly on. Is that a positive value or a negative value? Well, after much discussion, we put it in the positive column. I argued it was because the gist of it was, this is a terrible. Well, the point was, this heuristic encourages you to bash blindly on. Well, in some circumstances, bashing blindly on is exactly what you need to do. So, but you know, you could have a field day with just that question, in that single question in Math Overflow, with everything that people are saying, all discussions that are going on. So, if you focus on something more constrained. And again, we're focusing in Math Overflow on questions tagged group theory, which leaves out, you know, that sort of thing. It leads into more technical questions. There are 2,500 questions tagged with group theory, of which, if you look back at the structure of Math Overflow, you have questions, you have answers, and then you have chatter, you have comments. And if you just look within the questions and answers, 61 questions or answers contain beautiful, 26 contain elegant, 148 contain useful, and now we are getting on to more negative words. But, you know, still, there's more useful than, you know, useful is marginally winning. If you unpick, and this is kind of a compliment to what Matthew was talking about earlier in the week, if you unpick where beautiful occurs, it's quite interesting when you start unpicking it, actually, because you start. So beautiful occurs in 61 questions or answers. It tends to be mostly used by highly rated people. In fact, one person using 10 of those 61 are the same person. And one is me, and one is David still here? Yes, one is you. You said something was beautiful. You know? Yeah. I said a construction, a particular construction was beautiful. So 30% of them roughly are beautiful accounts or papers. It's more than beautiful explanations, because it tends to be people asking questions, where can I find about blah? Well, go and read this beautiful paper, this beautiful essay, this beautiful Wikipedia article, or whatever. Beautiful theorems, beautiful objects, examples or constructions, beautiful theories as opposed to theorems. Not so many beautiful proofs, I think, because people tend, well, you can speculate why that is. Some ugly proofs. What makes a proof ugly? Well, typically it is the bashing blindly on, or the humongous big construction, or whatever, an ugly example, an ugly lemma, ugly code, and so on. So you can start thinking about that. But you can also start looking at how the words are used, and we didn't actually, one could spend a lot more time investigating what I'm about to say than we did, but you know, start looking at the words not just as words describing beautiful theorems, but as part of a sort of power relation, or a relation, you know, who's allowed to call things beautiful, who rates things highly. It's not who is, you know, who owns things in these conversations, and who doesn't, and then it gets too sociological for me, but not for some of you guys. You know, it's you could, you know, who's allowed to say things, who gets rated highly, and typically in Math Overflow, it's, well, in this lot, they're mainly not anonymous, and they're mainly, it's a small world, and they use their own names, and mostly people who understand the technicality know who they are anyway, you know, so there's a lot of, and it's a curious thing, so I'm rather wandering from my point, but it's a curious thing. On one side, there's a value of mathematics, which I think we touched on earlier in the week, that there is, if you know how to play the game, it is open. You know, you could be a PhD student from the other end of the world who knew how to play the game, and you could ask your question on here and have it answered by one of the top mathematicians. But at the same time, it is about strutting your stuff and demonstrating power, and there's something else going on alongside the openness, which people who know about these things can explain better than I can. But it's not just writing down words about groups. It's more going on than that. You know, when you consider these are the people who are going to referee your papers, write your bet your tenure applications, and all the rest of it. Okay, well, that's one kind of backstage activity. Another kind of backstage activity is polymath, which we've mentioned several times today. Polymath, mathematicians collaborating on a blog. This is the article that Tim Gowers and Michael Nielsen wrote about this in Nature. And, well, here we are, so it fits with exactly the comment somebody made after the last lecture. Who would have guessed that the working record of a mathematical project would read like a thriller? This really does show all the dead ends and the red herrings and whatever. What happens if you start, and there are various social conventions about how to behave on this, in taking part in this conversation. And here's an example of a chunk of conversation. Nilim and Egan on September 17th, so just about a year ago, posted something or other. This observation is interesting, let's do something. But informal mathematics, you know, very consistent with what we were hearing about in the last presentation. Well, you know, you think about it a bit, and then you make it more formal, and Terry Tow's saying something or other. Terry Tow can't work out the nodal line for that in his head. Well, jolly good. Terry Tow can't, then the rest of us probably can't. And so on. They also have that, the big polymaths have taken, they've been, a number of them now, and they've tackled research math problems. They've also had some experiments called mini polymaths, which are taking problems from the Mathematical Olympiad. This is a problem about rotating lines called the windmill, and here's a chunk of the discussion going on. Somebody's saying something, somebody else is saying, no, that isn't true. And so on. So you can follow the ebb and flow of the argument. And in the work we were doing on this, we went away and analysed it in a very simple-minded way, just to see what was going on in this conversation. There are, do you want to go back and see what the number is? Yes, there are 174 comments in 27 comment threads. And, well, what was going on? 20% of it was conjectures, 10% of it was concept, discussing concept, only 14% of it was proof steps. A lot of it was playing with examples, and then a lot of other things that were social glue. So the final bit that would be written down was only that, just to pick up on what I'm saying about red herrings and so on. Okay, well, so what happens if you start looking for the expression of mathematical values in these kinds of mathematical arguments, the ones that include the red herrings and so on? Well, what we did was just to pick up on the work of Andrew and Matthew that we were hearing about on whatever day it was, yesterday?
No.
It seems a long time ago. And just start looking for the occurrences of words to try and understand what was going on. And so here we're counting, what words are we counting? We're counting useful and beautiful in the blue, and these are per 100,000 words. The blue is the mini polymaths, the red is the big polymaths, the polymath activities that take many months to crack. The green, for want of a better thing, is the British National Corpus, although maybe we should be doing something more sophisticated than the British National Corpus, like papers in Nature or papers in Mass Journal, I don't know. And so, well, what do you see? Well, compared with the British National Corpus, we've got a heck of a lot more usefuls in these two, somewhat fewer beautifuls, an awful lot of minimals. I think that's because one of the mini polymaths is talking about a minimal counterexample a lot. That's the downside of doing this. And precise, we've got rather more occurrences of the word precise in the major polymath, but none in the mini polymath. And then there's the yellow thing. I'll come back to the yellow thing in a moment. What's that, if it's not either of the polymaths or the British National Corpus? Well, then we picked up on, well, this, yes, they have been contested. Is that the word one uses? we've had a lot of fun debating Andrew and Matthew's characterizations, but they've given us something to use in other things. Categories of words rather than individual words, so we had words connected with aesthetics, words connected with intricacy, words connected with precision, words connected with utility. And when we look for those in the mini polymaths, the big polymath, the British National Corpus, and the thing I haven't told you what it is yet, well, aesthetic type words, beauty, etc., well, rather fewer of them in the polymaths than in the normal run of conversation. Words denoting intricacy, rather more of them. Words denoting precision, almost, except for the yellow thing, almost the same as the British National Corpus. Words denoting utility, usefulness, beating the British National Corpus. What do we deduce from that? Well, of course, you may be wondering what the yellow thing is, except for people who know, because I've already told them. Any guesses what the yellow thing is? It's a corpus. It's proofs and refutations. And so, proofs and refutations, is that backstage or front stage? Or is it a play within a play? Or is it, well, whatever metaphor you want. It's a novelist writing about. It's a novelist writing a kitchen sink drama. I don't know what it is, but it's yes. But I mean, you know, when you look at proofs and refutations, that it's written in a completely different kind of language. And we were having a nice conversation at tea yesterday about where Lakatos got this style from. But you will see, but in a way it's a much preciser language. It's not the sloppy language of, well, not language is sloppy, it's current, fairly informal English, but conveying a precise meaning. Whereas this is, well, whatever it is, rather formal English of the 1950s being used to reconstruct an almost platonic dialogue. And you can see when you look, it's got words like falsifies and counterexamples, not to mention good show. And when you think about that language, you can sort of see where this is coming from. So proofs and refutations, we have a few aesthetics, good show. We have a heck of a lot of the words denoting intricacy, more so than in polymath and the polymaths, because the prose style of proofs and refutations is pushing forward the intricacy. No, wait a minute, no, what happened? Because of where are we trying to get? Precision, we're sort of off the scale of proofs and refutations. And utility, not utilities, proofs and refutations is not proofs and refutations to talk about usefulness.
You know what that is, because they're not actually trying to solve a problem.
They're not, yes. They're not trying to sell they're not trying to write an abstract which says, cite me. So, well, here we are, that's about where I've got to, what I have to say, except for one more, oh no, sorry, conclusions, a conclusion slide. So, what are the conclusions of all this? Well, let's be honest, myself and me, I won't speak for my two co-authors,